Far away, in the silent darkness of space, something extraordinary is about to happen. A giant star, once blazing with light, is nearing the end of its life. This is not the story of destruction. It's the beginning of something even more mysterious. Stars live long lives, sometimes billions of years. But like all things, they eventually run out of fuel. And when a truly massive star reaches that point, the universe prepares for a breathtaking transformation. For billions of years, the star has been a furnace of nuclear fusion. Hydrogen is converted to helium, releasing light and energy that sustains the star and bathes the galaxy in brilliance. But this magnificent process is held in check by the relentless force of gravity. At the star's core, nuclear fusion has been keeping gravity at bay for millions of years. This delicate balance is what makes stars shine. But once the fuel is gone, gravity begins to win, and the core starts to collapse inward. This is not the end, but a new beginning. It's a prelude to one of the universe's most enigmatic phenomena. Imagine something the size of our sun collapsing into something no bigger than a city. That's the scale we're talking about. This collapse is unimaginably fast and violent, but also beautifully orchestrated by the laws of physics. The star's outer layers blast out into space in a brilliant flash, throwing off a star's mass at speeds up to 18 kilometers per second. Meanwhile, the core shrinks at lightning speed, crushing atoms into a tighter and tighter space. This moment is known as a supernova explosion. The star's outer layers blast out into space in a brilliant flash, while its core shrinks at lightning speed. What's left behind could become one of the strangest objects in the universe. If the leftover core is heavy enough, gravity crushes it beyond the limits of normal matter. Atoms collapse. Even the space between particles vanishes. Here's how a black hole is born. It is not a place, but a boundary. At its edge, the gravitational pull is so strong that nothing can escape. Not matter, not light, not even space and time as we know it. This is the event horizon of a black hole. Nothing can cross it without vanishing from existence. Inside the horizon, the rules of physics break down. All we know for sure is that the boundary exists because nothing can cross it and return to tell the tale. The core of a black hole is a place called the Singularity. This is a point where all the star's mass is packed into an infinitely small space. Here, physics as we know it breaks down. We can't see it directly, but we know it's there from the way it bends space and time. To the outside universe, time near a forming black hole appears to slow down. This is called gravitational time dilation. To us, the star seems to freeze as it collapses, even though for the star itself, the process finishes quickly. This bizarre effect makes black holes feel like magic, but it's pure physics. Albert Einstein's theory of general relativity predicted all of this over a century ago, and so far, every observation has backed him up. Once a black hole forms, it begins to influence everything around it. Gas, dust, and even light nearby get pulled into a swirling disk, glowing brightly as they spiral down. This is how we can detect black holes, even though we can't see the black hole itself. Some black holes remain quiet, hidden in the dark. Others become cosmic engines, blasting jets of energy across galaxies. These are the seeds that can grow into supermassive black holes, millions or billions of times the sun's mass. But at their core, all black holes, big or small, start the same way, with a star that lived and burned and died in spectacular fashion. It's a reminder that endings can also be beginnings. In the early universe, black holes may have formed even faster, helping shape the first galaxies. Some scientists think they were born only a few 100 million years after the Big Bang, guiding the growth of everything we see today. And here's the mind-bending part. The matter that once made up a shining star is now locked beyond reach. Forever. It hasn't disappeared, but its information is trapped behind the event horizon. This mystery has sparked huge debates among physicists. Where does the information go? Can anything ever escape? These questions still drive cutting-edge research even today. When you look up at the night sky, some of the stars you see may be future black holes still burning now, but destined to collapse and begin their second life as silent giants. Despite their terrifying reputation, black holes aren't cosmic vacuum cleaners sucking up everything. You'd have to be very close to be in danger. From far away, they act like any other massive object. In fact, if our sun magically became a black hole of the same mass, Earth would keep orbiting as usual. It would just be dark and cold. That's how misunderstood black holes really are. So, instead of monsters, think of black holes as natural parts of the universe's life cycle. They are the quiet, invisible heirs of the brightest stars. Their story isn't about destruction, it's about transformation. They recycle matter and energy, shaping galaxies and carving the architecture of space itself. Even though they're invisible, black holes leave signatures all around them. Ripples in space-time, called gravitational waves, reveal their births when two collide in distant space. Thanks to observatories like LIGO and Virgo, we can now listen to these cosmic events like distant thunder, hearing the universe announce a black hole's arrival. And with the Event Horizon Telescope, we've even captured the silhouette of a black hole's shadow, the first ever image of something once thought to be purely theoretical. Every discovery shows us that black holes aren't rare or exotic. They're common. The Milky Way alone may contain hundreds of millions quietly drifting among the stars. Now, let's talk about something strange. You see, the universe doesn't just have black holes, it also has wormholes. And get this, wormholes could be hiding inside those black holes. Yep, you heard right. Here's the deal. Black holes are like cosmic funhouses. They mess with your sense of direction. If you were to zoom into the center of a black hole, you might find yourself popping out somewhere else in the universe. That's right. Space gets all twisted up in a black hole, creating these wacky shortcuts called wormholes. These wormholes are theoretical. We haven't found one yet, but scientists think they could exist. One idea is that when a star explodes as a supernova and leaves behind a black hole, it could also create a wormhole. Now, this wormhole wouldn't be hanging around for long. It's probably too unstable to last very long. But that doesn't mean it can't do some damage before it disappears. Here's what could happen. Some stuff from the star, maybe parts of the star's core, could get blasted through the wormhole during the supernova. That stuff could end up in another galaxy far, far away. It's like a cosmic game of hot potato, but with a black hole and a wormhole doing the passing. This idea helps explain some weird things we've seen in space, like finding a bunch of iron near a black hole. Iron usually forms from exploding stars, but how did it get so close to this black hole? Well, it might have arrived via a wormhole. So while wormholes are still a mystery, they might hold clues to understanding how things move around in the universe, especially near those funky black holes. It's a reminder that the cosmos never ceases to amaze. Who knows what secrets those black holes are hiding? So instead of being afraid of them, let's marvel at the amazing things they do. They may seem scary, but they're just doing what they're supposed to, shaping our universe in ways we're only just beginning to understand.